So now we'll discuss about piezoelectric and ultrasonic transducers. So piezoelectric means is an electroacoustic transducer used for conversion of pressure or mechanical stress into alternating electrical force. That is physical quantity like force, pressure, stress directly not possible to measure. So it converts a physical quantity into electrical voltage, which is easily measured by analog and digital meter. So the material which shows such properties is known as electroresistive element. The quartz is the example of natural piezoelectric crystal. Piezoelectric effect means the EMF is developed because of displacement of charges. So the pressure is applied to the crystal with the help of force summing devices. For example, the stress is applied through a mechanical pressure gauges and pressure sensors. The deformation induces a EMF which determines the value of the applied pressure. So in the diagram you can see the force is given and the changes in the size, that is deformation, the output voltage gives the piezoelectric effect, that is EMF is developed. The voltage sensitivity of the crystal is expressed by the ratio of electric field intensity and pressure. So the piezoelectric crystal is direction sensitive. The polarity of the voltage depends on the direction of force, which is either tensile or compressive. So properties is piezoelectric material has high stability and available in various shapes and sizes. The piezoelectric material has output insensitive to temperature and humidity. Next is the ultrasonic transducers, that is a sound that is generated above the level of human hearing range is called ultrasound. Ultrasound typically starts from 20 MHz. Most ultrasonic transducers start from 200 kHz. And the shorter wavelengths are what make ultrasound and ultrasonic transducers extremely useful for non-destructive testing. An ultrasonic transducer itself is a device that is capable of generating and receiving ultrasonic vibrations. The active element is a piezoelectric or single crystal material which converts electrical energy to ultrasonic energy. Applications of ultrasonic transducers are ranging and navigating, diagnosis, therapy and surgery, Doppler effect, medical imaging techniques. And next is the temperature measurement. So here thermometer is a device that measures temperature. Thermometers can be divided into two groups according to level of knowledge. That is primary thermometers, that is measured a property of matter is known so well that temperature can be calculated without any unknown quantities. And the examples of these thermometers based on equation of a state of gas and velocity of sound in gas. So angular anisotropy of gamma ray emission of certain radioactive nuclei in the magnetic field. Secondary thermometers means widely used because of their convenience. So secondary thermometers is the measured property which is not sufficient to allow direct calculation of temperature. Next is the thermocouple. It is a sensor for measuring temperature. Sensor consists of two dissimilar metal wires that is joined at one end and connected to the thermocouple thermometer. When properly configured, thermocouples can provide temperature measurements over a wide range of temperatures. So thermocouple amplifies with cold junction compensation diagram. So here you can see thermocouple, measuring junction, instrument and reference junction. Thermistors are the oxides of certain metals like manganese, cobalt, nickel, which have large negative temperature coefficient. Thermistors, when used for measuring temperature, have many advantages over thermocouples and resistance thermometers. That is different types is bead type, disc type, rod type. So the diagram it is given. Next is the infrared thermometers. It is used to measure temperature using black body radiation emitted from objects. So this is called laser thermometers. The amount of infrared energy emitted by the object and its emissivity, the object temperatures can be determined. Next is the liquid crystal thermometer. Thank you.